Hey, ladies and gents, today we're going to talk about z-scores. So z-score is just how many standard deviations a particular value is away from the mean. So if your standard deviation is 5 and your mean is 10, one standard deviation away would be 15. 2 would be, 20. Yeah. So that's what a z-score is, how many of those standard deviations your value is from the mean. If the z-score is positive, the data value is greater than the mean or above. Z-score is negative, is less than the mean. Now, what if z is equal to 0? That means it's 0 standard deviations away from the mean. That means it is the mean. So we have our formula, and again, these values, they're the population values, and sometimes you will use population, sometimes you use the sample data. But the z-score is equal to x minus mu over sigma. Okay? So that's your formula. Yes, you need to know it. No, I'm not going to give it to you. So let's just practice applying that formula. So whenever we read a problem, the best thing to do is write down what each value is. It says if the mean is 46 miles per hour, so that's my mu. And then our standard deviation is 2.8. So that's sigma. It says find the z-scores for the following. So z is equal to x minus mu over sigma. So for this first one's going to be 52 minus 46 divided by 2.8. Throw that in the calculator, see what it gives us. And we get 15 over 7, or 2.14. So for z-scores, whenever we're calculating them, we're going to write down 2 decimal places. Whenever we use them to actually find probabilities, we're going to use the whole fraction in the calculator. Whenever you get to college, if you're looking, a lot of professors like to use the charts, so you will look for 2 decimal places. So you'd round this to 2.14, and you look 2.14 up on your chart to find out what that z-score is. I'll show you that in a minute. To find out what the probability is. So 2.14 is what we're going to write down. But if I were using it inside of the calculator, I would actually use 15/7. So this next one. Plug it in the formula. Change that 52 to a 42, and we get negative 1.43. So remember, if it's positive, it's above the mean. 52 is greater than 46. If it's negative, it's below the mean. 42 is less than 46. All right, so 47 minus 46, so that's going to be positive something. Change that, and we get 0.36. All right, so what does this mean, really? So if we look, let's see if I can pull that chart up real quick. Give me a moment, please. Here, remember this guy? So this is the mean. This is how many standard deviations each away from the mean each data value would be. And if you remember that empirical rule, we can use that to estimate the probabilities, right? Well, we're actually going to use the z-scores to calculate those probabilities. So I brought it up right there. There we go. So we're going to calculate the probabilities in just a minute. For now, we're going to practice using that formula. So it says the mean number of miles each move around the track was 4. So move is 4. With a standard deviation of 1.2. Clay's z-score was 2.5. So z is 2.5. And we're looking for x. How many miles did Clay run? Same formula. Remember, it's z equals x minus mu over sigma. So we just plug in what we've got. 2.5 equals, we don't know what x is. Minus 4 over 2.5. No, 1.2, sorry. Looking at the wrong number there. So solve that. 2.5 times 1.2. And then we're going to add 4 to that. And we get 7. So Clay ran 7 miles. Test papers are normally distributed with a standard deviation of 5. Riley scored an 83 with a z-score of negative 0.4. What was the mean? So let's write down what we've got. Standard deviation is 5. The score is 83. The z-score is negative 0.4. And we're looking for the mean, mu. So plug it in, let's see what we got. Negative 0.4 equals x minus mu over sigma. So it's at negative 2 equals 83 minus mu. Okay, so that's negative 85 equals negative mu. So mu is 85. So that's, she scored an 85 on that test. The heights of a group of trees is normally distributed with a mean of 14.3 feet. If the z-score for a 20-foot tall tree is 1.9, what is the standard deviation? Okay, same process, set it up and solve it. All right, so solve this thing, 1.9 sigma equals 5.7. Divide, and we get sigma equals 3. Let's keep going. A normal distribution is a distribution in which the mean is 0 and the standard deviation is 1. So that's a standard normal distribution. Mean is 0, standard deviation is 1. And we standardize it using the z-score. Here we go, probabilities. Remember, we said that probability is the area underneath that curve. So we can find the area of this thing, we can find the probability of being that value or less. Now, I'm going to do this strictly with the calculator, but I will show you how to use a chart. So for z is less than 2.1. It's very important that we're dealing with a z here. We are. That means it's already standardized, so we don't have to do anything to that value. Excuse me. We're going to plug it in the calculator. This is a normal distribution, so we're going to go to our distributions. Mode down, number 3 is distributions. It's a normal distribution. We will never use a normal PD. I can't think of a time where a normal PD would be used. I just can't do it. Sorry. Normal CD, that's where we're at. Now, if we look at the options, it says lower, it says upper, and it says standard deviation and mean. Okay, I just typed in the right number, so that's useless. But what we need from here is, where are we looking? So remember, if we think about the graph of this thing, so the Z is here and less. So this would be everything less than whatever that Z score is. For this one, Z is less than 2.1. So that means we gotta go all the way to the left. What number's all the way to the left? Negative infinity, that's our lower bound. However, we don't have an infinity button on the calculator. So we use a really, really, really big negative number. The negative number I use is -1 followed by 99 zeros. So I just type in 0 99 times, that works. You see this button right here, scientific notation, times 10 raised to the, so we're gonna go -1 times 10 raised to the 99. That is our infinity. So this is our lower bound because that is what we use for infinity. One more, please. So this is what it looks like. So you do -1, and you don't have to hit the -1. You can just hit negative. It'll understand there's 1 there. And then we're going to use the times 10 raised to the button. This is the button. And you can put 99. That's what we consider negative infinity. And positive infinity would just be 1 times 10 to the 99. That's my lower bound. What's my upper bound? 2.1. So if I go to my calculator, negative infinity, upper bound, 2.1. No standard deviation mean, we're going to leave alone. We're going to standardize everything. Yes, it can calculate without you doing the work, but I'm going to make you do the work. I want to see you convert those data values to Z-scores. We get 0.9821. 4 decimal places is what I'm looking for. Let's look and see how we could use the chart to this, because in college you will need to use the chart that you're almost certainly going to see. It might be slightly different from this one, but it'll be the same numbers and the same concept. Here we go. Okay. Let's go to the next one. So let's look at this one. I'm going to go back to that one in a second. X is less than 74. Don't do anything with that at 74 right now. We got to convert this to a Z-score first. X minus mu over sigma. That's what we need to do. So X is 74. Mu is 76. Standard deviation is 2.6. Got that in the calculator and see what happens. 1 for that. Minus, did I have 46? 76 over 2.6. So we -10 over 13. That's what I'm going to type in my calculator. But if I'm looking it up in the chart, it's -0.77. I don't know why I put a 4 there. That's definitely 7. There we go. All right, sorry about those technical difficulties. We're back. So you'll have some sort of format sheet like this. And yeah, you scroll down, you should come to a chart with z-scores. Here's one for negative z-scores, one for positive z-scores. So we're going to go, let's look at the first one. We'll do both of them. We have a z-score of less than 2.1. It's very important to realize that this chart is only for less than, left tails. We have to do some math to get the other ones, but 2.1. So it is a positive 2.1. So we need positive z-scores. 2.10. So this is your hundredths place. This is your ones and tenths place. So 2.10 means we should have an area under the curve of about 0.9821. Look at that. For this one, it's a negative 0.77. So negative 0.7, and then go until we get to 7. That's this column, third to last column right here. So we should have 0.2206. And if we do negative 10 over 3, 1 minute please. Sorry about that, I'm back. All right, so if we look at here, negative 0.77, we didn't actually find the probability of that yet. It should, negative 0.77 should be about 0.2206. Let's find out. We're going to use the negative 10 over 13 to calculate those. So that's going to be our upper bound, and negative 10 will be our lower bound. Lower bound negative, and you could either do 1 or not, times 10 to the 99. Upper is negative 10 over 13. And yes, it's perfectly fine that it does this. Again, I hate this kind of type, but it works. And we get 0.2209. So it is going to be slightly different because of our rounding issues, but 0.2206 versus 0.2209. Yeah, pretty dang close. 6 in the chart, it was 9 on the calculator. And again, I'm going to let you use the calculator so you don't have to worry about the chart. But I figured it was good to show you because that should be using Nesher most likely. I'm also going to show you how to do a greater than and a between. Now for this one, again, same concept. This is a z-score, so we don't have to convert it. Negative 1.5, z is greater than that. So negative 1.5 is going to be my lower bound. My upper bound is going to be infinity. So lower bound, negative 1.5, upper bound, 1 times 10 to the 99. Leave those alone. We're doing standard normal, 0.9332. Okay. Now, if you're going to use a chart, remember the chart gives you the left. Gives you the area to the left. So to find the area to the right, you can do 1 minus whatever you get from the chart because, you know, the whole thing adds up to 1, right? So where are we at? Greater than negative 1.5. Negative 1.50 is 0.0668. So 0.9332, let's see how close that was, 0.9332, same, with rounding is even the same, okay, cool. Oh, it's negative 1.5, yeah, it's nice and not rounded at all, should be the same. This one again, it's a it's an x value, so when you convert that to a z-score first, chart same thing, just convert to a z-score and then do 1 minus. 81 minus 76 over 2.6. 25 over 13 is what I'm going to use in the calculator. Fraction is a decimal of 1.92. So it's 0.9726. We do 1 minus that because we're doing greater than. 1 minus 0.9726 is 0.0274. So we should get something about like that from the calculator. Let's find out. CD lower bound 81. Oh no, we're gonna do 1.92. We're gonna do 25 over 13. Use the fraction. Upper bound is infinity. Leave those alone. 0.0272. Okay. Probability. That same thing. Chart. What do we get here? So compare those. 0.0272 versus 0.0274. Pretty dang close, right? All right, now between. So, oh no, what's my lower bound? What's my upper bound? This is your lower bound. This is your upper bound. Wow, so hard. Not enough. The right buttons here. Lower bound is negative 0.2, upper bound is 1.8, and we get about 0.5433. Now, to get this from the chart, if we think about what this is, if we look up negative 0.2, negative 0.2, this will give us negative 0.2 and to the left. If we look up 1.8, that'll give us 1.8 and to the left. So let me just grab this for a second. This is negative 0.2. And this is 1.8. So if I look up 1.8, where's the highlight right here? It's all this stuff and this stuff, right? So you can probably see visually what we need to do, don't you? Don't you? I hope so. That's right. We're going to look up 1.8 and we're going to subtract the 0.2, negative 0.2. So 1.8 first. Let's see what's up. 1.80, right? Yeah. 0.9641. Minus negative 0.2. 0.2. 42.4207. And we should get the exact same thing, 0.5434, 0.5433. Oh no, a whole 10,000th off. So yeah, that's how you do it. All right, last one. Same thing, but we need to convert both those to z-scores. 77 minus 76 over 2.6. 83 minus 76 over 2.6. we get 5/13, which is about 0.38. (35/13), which is about 2.69. Lower is 5/13. Upper is 35/13. Those alone, 0.3467. Might as well just find out what it is on the chart. 2.69. 2.6. Last one's 9. One, oops. Then 0.38. So 0.38. 38 right here. It 0.3484. That was a little further off, which since we had to convert to z-scores, there was a lot more rounding involved. So yeah, it's still pretty dang close though, right? And guys, that's z-scores for you. See ya.